Alright, so in this video we're going to be working on the integral of cosine cubed x. Now, you might already be familiar with the integral of cosine. We know that's just going to be sine x plus c. And you may also have come across the integral of cosine square x dx. So in that case, what we do is we perform a trigonometric substitution, and then all we need to do is we need to say, okay, so this is actually equal to half plus half of cosine 2x. So we can write it in this form. So now the idea behind that is that you get a substitution for a cosine that is to the power of 1, which is quite easy to integrate because you already have this result which you know. So then all you do is you integrate this and then you integrate that. So the integral of 1, so you have half times the integral of 1, which is x. And then the next one is going to be sine 2x, but you're going to have to divide it by this constant at the front of x, which is 2. So you have 1 over 2 times 1 over 2, which is 1 over 4. And that gives you the result for that integral. And if you want to know where this comes from, this actually comes from something called de Moivre's theorem, which is a theorem that is used in complex numbers. So if you want to see how this is derived, I have posted a link in the description that takes you to that video where I have explained how to do this kind of thing using that theorem. Now, suppose you're given a higher power of cosine, and in fact we're going to derive a method that works for any odd power of cosine or sine for that matter. So the idea behind it is that you're going to have the following expression. Instead of writing it this way, let's write it in terms of cosine x times cosine squared x. Now there's nothing wrong with this because all we're doing is, well, this, if you multiply this times that, it gives you cosine to the power 3. Now what you're going to do is you're going to substitute for this in terms of something like sine. So you can use the substitution sine square x plus cosine square x equals to 1. And then if you rearrange for cosine, you get cosine square x equals to 1 minus sine squared x. And you're gonna see why I decided to do that substitution in a while. So now we're going to put this expression in here. So that's 1 minus sine squared x times dx. Alright, so the reason I decided to do this substitution is because we have a product of two different functions. Now, if we want to use the method of substitution, then what we need to do is the derivative of one of these functions needs to be equal to the other function. So in this case, it makes more sense to perform the substitution here because it is the more difficult function. We know how to integrate this, but we don't know how to integrate this, like at least not in a simple way. So how about we make u equals to sine x such that du is going to be cosine of x times dx. And now if you notice what we have here, the other function is cosine of x and it is multiplying dx. So now we can perform a simple substitution here. So we can say this is equal to the integral of 1 minus u squared times du. And now we know how to integrate this because we just have this, which is u to the power 0, and this is u to the power 2. So all we do is add 1 to the power, divide by the new power. So this becomes u to the power of 1, and then this becomes minus u to the power 3 over 3, plus some constant of integration c. And now to take this back into the original form, all we need to do is we need to substitute back for the original function. So now we're going to get sine of x minus sine cubed of x over 3. And then plus the constant of integration c. And you might be thinking, well, hang on a minute, if I differentiate this, it doesn't really become cosine cubed x, does it? Well, let's have a look at it. Let's differentiate this function with respect to x, so let's see what we get. This function is going to become cosine of x. The c is going to become 0, so we can ignore it. Now here, you're going to use the chain rule, so you're going to differentiate the outside, which is just the cubed. You're going to bring the power down, so that becomes 3 sine. Now subtract 1 from the power, that's 2. So sine square x over 3. The 3's are going to cancel out. and you're gonna be left with, well, you have to differentiate the function inside, which is the sine of x. So you're gonna multiply this by cosine of x. Alright, so now what you notice is that you can actually separate the cosine. You can factor it out of this equation. So you have cosine of x times 1 minus sine squared x. And now if we look at the original trigonometric identity that we used, it turns out that you can actually substitute back for cosine x squared, which is here. So cosine square x. And then this becomes cosine cubed x. So it turns out that by doing this rather clever manipulation of the integral, we get the correct answer once again. And you wouldn't expect this to be the answer, but it turns out that the actual integral for this is going to be a sum of sine x minus sine cubed x over 3. And in the next video, we're going to continue on this by looking at more general examples and higher powers of cosine.